Hello, in this video I will show you how you can increase your FPS in the games with your stat commands, how to intercept issues like drawbacks or maybe some FPS losses, and what is draw calls, triangle count, and I will show you on the example a little bit how you can make optimizing and default Unreal Engine tools and how to work and intercept issues inside Unreal Engine. Okay, let's start. Here I have the default scene. It's third person example, and inside I will show you some basics with the stat commands what I just used for make optimizing. And from the start you can play and press tilde key near escape button, and you can write your what you need, like some custom stat commands for optimizing. For example, stat FPS, just very simple, and it shows on here right side FPS, and if we will have some drawbacks or losses, we will see on the screen. It's stat none. It's just disable my stats. Now other stat will be stat, very important now, stat scene rendering. This stat is very important with the draw calls. You will see the draw calls, what is current draws from your GPU, and you can see them inside here. I just will move and draw calls. Now we have 22 draw calls, for example, and I will show you what I mean about the draw calls. And you can see right now we have only 40, 16, okay, 26 more, 26, 32. It's much bigger, and we will have lesser FPS inside. And what is mean? What is the draw calls from the start? I just write a little log, little image, and inside we have the draw call and item. And draw call from very simple. What is just? It's when your CPU say, okay, GPU, draw me this model, for example, and your processor just said, okay, GPU, please draw this mesh with the material, but your draw call will be the material, and every mesh needs to be with one and more material, but your material, it's one draw call. Like if you will put two walls, you will have two draw calls. But if your mesh will be with more materials, for example, you will have here two materials, right? 0 and 1. This full model will have two draw calls inside, and it will be more harder for render. It means when you have a lot of materials on your mesh, you will have lower FPS inside performance. And what this means, like you have your static mesh, here your static mesh, the item, static mesh, and you have draw call. If you have only one material, you will have one draw call. If you have four material, you will have four draw calls, and it will be increase. And if you have a lot of draw calls inside your scene of view, you will have lower FPS. Yeah, because you render those materials to your view, and it takes GPU memory. And if you have the very heavy, for example, translucent materials or big 4K or more textures, it's take a lot of memory inside GPU for this material. And it means like you have one item, one static mesh right now, for example, one static mesh, but with four materials. It's like you have 4 boxes inside. It's very simple how to show you. Yeah, like 4 boxes. The best quality of assets is when you have one mesh and only one draw call inside. Its PBR material needs to be, and it will be best optimized like for mobile. And also for mobile, it's great when you have not a lot LODs, like not 10, not 5. 3 or 4 will be okay, but not more 4, because every switching LODs will be on your CPU. And it's cost also memory on your CPU to check some LODs. And I will show you right now about more draw calls, some info. I will delete this, and or maybe I will delete from this angle better. And what I want to show is how you can find your draw calls. I will put the default cube in one material, and I will copy it a lot of times. It's now we have 1, 2, 3, 5, okay, 7, 8, 9, 10. Okay, we have 10 cubes now. I will make more copies now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's for testing this great stat scene rendering command. For disabled right now, stat none you can write, and you will disable your stat big window, and it's more better to check and see something. And right now we render them all because we are watching on it. If I will watch this angle of view, they will be not in the render. It's great optimizing from Unreal, and if I will look to them, I will render them and I will load full materials inside my GPU, and CPU said, okay, GPU, we need to render them, and we have right now rendered from the GPU those a lot of cubes, maybe 100 I think. And for checking, I will write start um, start uh, rendering. Yeah. And you can see now we have a lot of render on the average. It's right here. It's a lot. If I will look out, 22, like normal. And render view family, you can also see it will be increased. And if you will have the dynamic shadows, dynamic lighting, a lot of post-process, and it's actually will take a lot of resources. And if you will have those guys inside mobile or VR, it's very not great for performance. And to fix that I will show you later how you can work with it, how to solve this big draw call count with the Unreal default tools. For now I just stop it. Stop none. Okay, let's go more. Also we have great commands to check the GPU. Right now it's Control Shift and comma, and we have the GPU visualization, and here it's just like static on the level. I will show you later how to use with the stat inside dynamically, because you can maybe spawn something on load, something also with the level, and you can see some lighting, how much it's cost, and you can just sort them from the bigger. For the first, it's just post-processing. You can see it takes a lot of the most some materials, and for the uh, post-process, I think it's because it's on the full whole of the map right now selected. Yes, now it will be better with the optimization. Let's check it. I will close this window and open again, Control Shift, comma, and we will check again. Okay, it's not a lot helped. You can see also what exactly takes some like blooms and other parts of the, but this tutorial not on the post-processing. You can play with them. Okay, let's move more. This is just static. Other, it's start great when you can check your event and maybe heavy blueprint some logic. For example, you have the big scene and you have very optimized materials models, but your FPS is still low. Maybe it's because you have a lot of event and heavy logic with the blueprints, and you can check this also with the stat. It's dynamically. Start game. Here is very important. You can see its world tick and tick time, and if you will have a lot of event tick, you will see them also. And it slow down your performance. Don't use event ticks if you don't need them, and don't use please heavy logic with like get L actor of class or checking something all of the time. It's very heavy on the performance. Okay, let's move. Now, one great also stat for now not draw calls on the dynamically of your angle of view now with the triangle count. It's very important. Most of times the heaviest is dynamic parts, draw calls, triangle counts. It's like the core what take it performance, and lightning also can be, but dynamically it's not a lot to reuse, just set to the static. And now start RHI. This start helped us to see dynamically how exactly we draw triangle count. Here, triangle draw, you can see, and we have the draw and also the texture memory, how much we load inside our GPU. And for example, if I will not, it's all-time load. Okay, it's not great settings inside the rendering, but if you will have like VR and uh, rendering, forward rendering, in the project settings rendering, you will not render these guys when you will not looking for them. Yeah, and it's just for now and for PC. We draw them all by the time, but if you will have, I will show you this forward 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 shading. But you need to use it with the MSAA. Yeah, and you will able to load only what you can see. But with them you can also use level streaming. It's a big part, but I can make a tutorial also about this later. And you will see the triangle count what you just draw inside, and it works also dynamically. Start, it's from now basic start unit graph. It's, you will see the little screen with the performance, and MS is just better than default stat FPS, and you will see MS, it's milliseconds, how much previous drove will take time. If it's less, it will be better. For example, if I will not, will like here, And you can see we have some changes on the graph. But it's only basic, it's just not great for big optimizing. Start known, no, startnet, but it's not for like optimizing for FPS, but it's optimizing for multiplayer game more. Also, you can use profiler, but it's not for beginners. It's more when you have loads and unloads, and maybe sometimes you have some lags, and you can intercept that with the profiling. You can use also from the command start file, and I am now writing the file, and if I will have some drop losses, like, or maybe some issues with the performance for a little bit time, like 1 second, I can intercept with this, but it's a big also part. Start stop file stop, and it's I think all from the optimizing. One more thing, start GPU. GPU, yes, it's like with the post-processing, it's like you had previously what I show you with the shift, control, and comma, but it's dynamically. And you can see with the post-processing dynamically and how it's take lighting, also shadow. Okay, start none. Okay, from this part, I think the start is fine right now. And what you need to also know, when you have the new level and you don't know a lot about the level, and what is more, you have the out of limit like triangle count or drop holes, you can check from the start. It's the best, I think, when you can open, I will show you window, statistics, and here we have the window, great primitive stats window, and inside we have all objects type like static mesh, actor, and other skeleton mesh. Account, you can see we have a lot of cubes here, and for grade you can sort them for the triangle count, and you can sort them and check how much you have triangle count, and you can think, okay, you need for mobile, for example, 200 only, and you can optimize for the 200, and you can optimize from the biggest objects, like from this mannequin cubes. You can work with them with optimizing to make less triangle count, and you will get the better performance inside. It's for the triangles primitive. Lighting we don't have, I think, nothing. We have right here lighting. It's great when you can see the static mesh resolution. For example, I will put this sphere inside the level, and I can change the resolution. You can see it's lighting resolution. I can press like 4K. Okay, we have 4K now texture, and it means you will have very great and realistic shadows from this model when you will make a build. But it will draw a 4K texture here, and it's very bad for performance when you have a very big like texture. And from the start, I think we will see the update. You can press refresh here, and you can see we have this sphere. We can select also it, like I will select cube. When I press the sector, we will select the selected actor, and you can exactly see what it is. And if we have 4K texture, and we can see how much it takes for the GPU. It's a huge count. Like it's very a lot, very, because it's 4K. And it's how you can see the also bad thing what can happen. Textures also great when you can sort. You can see all textures what you use it inside the project. Memory inside, how much it takes. More normal is mm, the most of the, yeah, the biggest like boss inside. Normals also take more memory, and we can sort them and we can also play with them. uh, like we have this normal, we can for example make compression but or load BIOS. It's optimizing from Unreal, great working, but I will say just normally, and it will be more light for the package. When you do package, I will make a limit for the texture size, max size texture, and 1K. Right now you can see it's take it. We display 2K, and you can see the like scale and how it takes kilobytes. Like now 2K, we have a lot, like 4 times more, and a lot like 4 times less right now. And it's also optimizing when you make a less texture size to take less GPU memory, and it's nothing like most of times you will work with the primitive stats to decrease the triangle count of your view. And to know how much you need to optimize, I found it. It's just on the FPS and testing and performance analytic. And you will have the requirements for this platform like Oculus Quest, and it's for Oculus Quest 1, 72 FPS, and you need to have on your view from 50 to 100 draw calls per time, and not a lot also triangle count. But if you will have the forward shading, you can make a lot more, and you can also use level streaming. For example, you can like you have the player here, and your player is can looking for this view, this angle of view, and you will render only models here. Other models will be not rendered here with the forward shading, and it's great way. Or you can play with level streaming. It's when you have your level 1 and you are moving from this level, for example, to the other level, right? You can put here a volume that will unload this level. We will unload this level from the memory, and we will load the new one. And only from here we will have the L2 level, what we just loaded. And you can play with this because you will not have a huge big level all into the memory. You will dynamically unload this when you need it and load this one new and play and do it again. It's with the level streaming great way, but it's a big part also. If you want, you can write the comments below under the video, and I can make a tutorial about the level streaming. It's a very great way to make optimization. And you can Google also and search for any of the platform like PC or maybe exactly some mobile or PlayStation or Xbox as a limitation, and do your project for that limitation. Also, you have here great debug tool, this from the Oculus, it's native, and you will have the great view window and you can see the drove losses. Now I want to show you about merging. Merging is a great way to optimize the draw calls. When you have a lot of models and you need to optimize them, like in this simple cubes, what we have on the scene. I will select them. Are this all? Not all. We have more cubes. And you remember when we just played, we had a lot of draw calls. Scene rendering, we have a lot of draw calls. It's at this level. When I'm just watching on them, because we render all of cubes now. And we have a lot, 200 more. Okay. And to play with this, we can make a merging. And I will show you two different parts. And for the start, I will do a copy of these cubes. And I will just put them like here. And visibility make hide. Do not render them at all. And for that other cubes, yeah, this one, yeah, I will do a merging. I will optimize these models. It's just for simple. I will show this, but it's a tutorial and also you will learn more. And we have from the developer tools here a merge actors. It's very great way. And we have three options here. First, second, and second. This all my cubes, what I just select, they are here. And I will play and start scene rendering. You can see we have a lot of like 200, near 200, like a lot, 200. I just select them. You can see I select all of cubes, what we have here on the right side, and we can merge them into one. What it will be do? Um, from my like package, big package, you remember maybe we will have, we had here a package box and we had there here item. And we have now I think 100 or more 100 like count of package of draw calls and for now I will merge this big count 100 plus boxes draw calls into only one, and you will have the same model. You will have the all those dudes here, but only with the easy and very light for render one draw call. I will show you how to do it. You can, we have selected it. First, harvest geometry. We have options like zero the pivot. If you want, you can put it, and it's great if you working with the components. But right now, it doesn't matter. We can use like with this one pivot, and in the end we will have the pivot right here on the merged model. UV not need. LEDs you can use a specific level. If you have, for example, you have the lowest LED, you can like 4, you can write 4 and you will have the lowest LED, but I don't have LEDs on this model. Replace means you will create a new model with all these cubes, and you will have one material and one draw call. It's very important. It's very optimized with one draw call. But replace source actors. It means you will replace the actors from the scene to exactly this position. Like I will write replace I will press merge actors. I need to, for this I will just put it to the content to make it faster, and I will do the save. Now you can see we have only one selected mesh with all of those cubes, and we have one material. It means we will have only one call to the GPU to draw this, and it's great for optimizing. It's very great. It will take low memory. Will not call to the GPU, "Hi GPU, please draw me this cube 100 and more times," and it's all time will cost the memory. Now we have only one material, and it's like in 100 less will take. One great cheat, what I know, I save it. This you can see, and with this my selected, I can make a Control Z, and right now I have the same full cubes, and also uh, I had selected my cubes right here, and I will delete it. Oh no, I will make okay, just I will put them. You will see, you can see it. We have the same position pivot, but not at the 0 because we did not select it. And now I will play, and we will see the difference. Haha, 21 only, 21 drop call. Collision works exactly, but it's better to use on the end of the project when you know you don't need to move some models, you don't need to change them, and on the polishing and finalizing you can merge them, and you will get the boost of your FPS. And it looks the same, but you will have the great optimizing. Okay, now for more I will delete this one mesh, and we have two more options here. Okay, I will back to the cubes because I need something to merge. And proxy mesh. Um, as I remember, this merge will merge great for the materials, but this one, be careful. Sometimes it's make merging of the materials, but they are not looks so beauty. But it's great when you have I will show you. For example, you have the static mesh with maybe 7 material, and if you will use this merging, this number second harvest geometrics, it's the same, but this one, and you will have on the merging only one material, not 7, only one, but with the not great quality actually, not great quality. And you can check the light map resolution, and you can see the material settings. You can merging when you merge you can make like lesser textures, and you can something add or disable if you don't need on the merge some textures. And um, maybe it's not the great way because we have one material, but it will work the same with a lot of materials, and you will get only one material. It means, well, like if you will have 10 materials here, from the end of this merging, this you will have only one material, but it looks not so beauty actually from my practice. And um, let's merge this again. It will take more time to recreate the materials, but we will have not only mesh, we will have the new materials and new normal map. It's a huge, really. It's a huge, and it's just great for us the material. It's not heavy material. And with this normal map and texture. Yeah, this one. Yeah, you can see it looks sometimes not so beauty. It's not a white color. Yes, we can play with the material, but sometimes it looks not great. And I'm using most of times this one to do less drop calls, and this one it's also great. Let's take a look for this one. No man. Ah, okay, we don't have the meshes. Ah, I just hide them. Okay, and this merging is with the components. It's great way. It's pretty close for this one, but here we merge for the one static mesh actor inside the scene, and here we will merge them to the one actor with the instance set static meshes. What it means? You will have the actor with a lot of components, but this component will be for all of them, and you will have the same optimizing of drop calls, but you can move your objects, you can move your components, because here you cannot move because it will be one static mesh. You cannot move or rotate some dude. From this you can do it, and you can select other classes, but actor is fine. And yeah, I think we can uh, just merge them into the one. You will see we have this actor. It's brand new actor with one instance and component what we just created, and that created uh, instance have uh, here instances, a lot of them, and you can play with him. For example, I will rotate, I will move up this dude, and I can also make a rotation inside or scale. I can manipulate with this, but it will be optimized like from the one mesh for the GPU. I will show you scene rendering. Uh, Not a lot of calls, and also you can see it's not a lot of calls. We don't have 100 of calls at all, and it's optimized, and you can rotate or move your every unique mesh. It's maybe better for changing something inside the level. Okay, it's just I showed you the basics, and for other part I will do the simple when I will check the real scene and I will do the optimization. Thank you for watching, and please press like button, it motivates me to make more video.